No. Oh wait, it is.
All right, here we go. We're going to continue with 1/6. There's one thing that I didn't cover yesterday that I didn't have in my notes, but it's from the book. It's page. The picture is on page 33. If you want to look, and I'm going to try my best to draw it. I don't have. I'm talking. Let me click on this first so I can draw. There we go. All right, so what if I had something like this? Like this. It's not going to be the prettiest thing in the world. Like that. This thing comes across, I think, something like that. It's close. And then let's go down like this. All right, I think that's everything.
That's like a mark.
Yeah. All right. So let me put a couple things on here. Let's put this in a different color. What if I said that this side, let's see, all the sides are equal to each other. Okay. Boom, boom, boom. Now, I just kind of drew it freehand. So if I actually measured this, all the sides probably would not be equal to each other. Okay, but putting those little tick marks on there, what does that tell you though? It tells you they're all equal to each other. Even though it might not look like it, we just have to make the assumption that they're all equal to each other because they tell us that, right? Now, they tell us this as well. They say that they put 2 arcs right here, 2 arcs right here, and all the other ones have 1 arc. So here's what this problem says. This is an example. It's example 3 in the book on this lesson. So the question says, classify each polygon by its number of sides. So let's do that first. They're going to ask you several different things, okay? But classify by the number of sides. So let's count up how many sides it has. 1, 2, 3, 4, 5, 6, 7. So what do we call this thing? Heptagon is what this book calls it, okay? It depends what book you look at. You could call it several different things, but this book calls it a heptagon, all right? So that's the first part. So yes, you need to know what all the ones are called. Up to 12. Okay, after that, there's really, I don't even know if there's names for all the other ones, but up to 12. Heptagon, H-E-P-T-A. I squish things a little together here, but that's heptagon. All right, so that's the first thing they ask. It says, then, state whether it forms a concave or convex. We didn't talk about concave or convex. Let's talk about that just briefly. Why does my phone keep on buzzing? Okay. It does, exactly. And you've probably heard that word, like maybe in science or something, concave and convex. But let me give you an example. Oops, of where's my, there it is. Click that, go to polygon, click that. Yeah, that's good enough, 6 sides. So this is an example of a convex polygon. I'll show you why. But it's a polygon. Hexagon is a polygon. All right, it doesn't matter how many sides, it's always a polygon. All right, so take a look at this. See the side right here? If I was to extend it, if I was going to take this side and extend all the sides, okay, so I'm going to take all these sides and I'm going to extend them all. Okay, so take that side, extend it, extend this side, extend this side, keep going, oops, extend that. Now some of these aren't really straight lines. I'm trying my best, but extend that, extend this, like so. All right, they don't all have to connect. All right, yeah, it's a star. That's not what I'm concerned about, okay? What I want us to see is if I extend all the sides, none of the intersections, like see how these lines will eventually intersect right here, like that? All the intersections are outside of the polygon. Everybody see that? So if I extend all the sides, it will never intersect inside the polygon. Okay, so what kind of a figure do we have then? That would be a convex polygon. Okay, so basically it's like this. Everything comes to a corner, and if I extended it, everything would extend out. Nothing would extend inside the polygon. Everybody see that? See, all of this is clean. I took all the sides, I extended them all, but this is all clean. Let's look at... we can get rid of that whole thing. Get rid of the geometry word. Right? What if I'm just going to make one up? Just make it kind of simple. And then make one like this. Put one like that. Let's see. Yeah, let's do one like this. And let's do one like this. Okay. Now, let's take a look at this one. Now, we have to decide, is it convex or is it concave? Those are the two words. It's concave because if I take the sides and extend them, if I took this side right here and extended it, let's do this. If I took this side and extended that out like that, and this side extended that like this, they don't go inside, do they? If I extend these two, that doesn't go inside, but guess what happens? If I extend this one and I take this one and I extend it, look what it does. Let's try and make it look like kind of a straight line. See how I extended that side? It actually goes through the middle of it, doesn't it? Not necessarily the middle, but it goes inside, okay, of it. And if I took this and extended that, that goes inside. So if you have this part right here, see how it goes inside and it goes inside the polygon, then I call that a what? A concave polygon. Everybody with me on that? So convex, if I extend the sides and it doesn't go inside. So basically, if your sides don't slant towards the inside of the polygon, then it's convex. If it does slant inside the polygon, then it's concave. You got it? So let's get rid of that. And let's go back to this one. So now, with this one, what is this now? Yeah. So it's a heptagon, and it's also what? Concave. Because if I took this side and extended it, it would go through it, right? Same thing with this side right here. It would go through it. So this is called concave. All right? Not everyone would, right? These don't go inside it. If you extend that, it doesn't go inside. Same thing here, same thing here, same thing here. Okay? It doesn't go inside. All right, so it's concave. Let's see, what else do they ask? How do we know? We just talked about it. We said if you extend the sides, if it goes inside the polygon, then it's concave. If they all extend outside the polygon, like the one we did earlier, then it's convex. All right? Okay, go back and watch the video if you didn't get that, okay? Because I just explained it. I don't know how else I could explain it. There's another thing that they're going to ask about this. It says state whether it's concave or convex. We already did that. It says concave. And then state whether it's equilateral, equiangular, regular, or none of them. Okay? So you hear our choices? Equilateral. What does that mean if it's equilateral? All the sides are equal. So, is this equilateral?
Yes.
Yeah. Every single side is marked with a little tick mark. So that is equilateral. Equilateral. Okay, so it's equilateral. What's the other thing I said? Is it equiangular? Why not?
Because the two angles at the top have
That's right. Two angles at the top have two arcs. All the other ones have one arc, which means they're not all equal to each other. Now there's 1, 2, 3. 1, 2. Did I count heptagon right? 1, 2, 3, 4, 5, 6, 7. Yeah. 1, 2, 3, 4, 5, 6. Oh, that's why. It's because I'm not counting this. Because on a convex polygon, the number of angles is the same number of sides. But this one, I guess this could be considered an angle, though, couldn't it? Okay, it's just more than 180 degrees. So that's why. So it's equilateral. Is it equiangular? No, it's not equiangular. What's the other one? Is it regular? Did we? Yeah, the very last thing I think we talked about yesterday was if it's regular. What does it mean to be regular? Did we not talk about it? Okay, regular means it's both equilateral and equiangular. So regular means all the sides are equal and all the angles are equal. So is this a regular polygon? No, because all the sides are equal, but all the angles are not equal to each other. All right, so it's not a regular polygon. And then it says, or none of these. Well, this is the one. It's not none of them. This is the one. It is equilateral. Okay, but it's not equiangular, and it's not regular, but it is equiangular. So these are the three answers to example 1A, or example 3A. I'm sorry. Yeah. What's that? Well, I didn't officially assign it yesterday, so I'm going to officially assign it today. So we're not going to go over the homework today. All right. So, do you have your books open or not? If you look at page 33, I'm not going to draw. It's just going to take me too long because I need to go on from this. Then it'll be tomorrow. All right. So look at page 33. Example 3. Everybody looking at it? So you got a book in front of you. Open it up. Page 33. Matsu, where's your book? Look at part B. First of all, the question is, classify the polygon by the number of sides. So look at part B. How many sides does that thing have? 1, 2, 3, 4. Right, so what do we classify it as? We don't just say 4 sides. We give it a name. What's the name? It's a quadrilateral. Good. All right, then it says state whether it's concave or convex. What is it? Convex. Very good. And then, is it equilateral? Look at it. Are any of the sides equal on that one? No, because one's got 1, the other's got 2, then 3, then 4. So, right, none of the sides are equal. So it's not equilateral. If it's not equilateral, then it's definitely not regular, right? Is it equiangular? Nope, all 4 angles are different, aren't they? So you would say what? Neither, okay? Or say none of these. All right, last one, part C. How many sides does it have? Count them up. There's 8. What's something you see probably every single day? A stop sign, okay? A stop sign is an octagon. It's not just any octagon. What kind of octagon do you think a stop sign is? It's a regular octagon because all the sides are equal, all the angles are equal. So let's take a look at this. Could this be a stop sign?
Yes.
Yeah, because look at the sides. They're all the same, aren't they? So that's equilateral. And all the angles are equal, so it's what? Equal, well, just because the angles. It's equiangular. So it's both equilateral and equiangular, so it must be what? Regular. Now, the answer in the book just says regular. All right, but you could also put equilateral, equiangular, and you can also put regular. Is it concave or convex? It's convex. Okay, it's convex because if I extend the sides, none of the sides will go through that polygon. Gio, what'd you say? Just regular. You can just put regular. They put regular. That includes equilateral and equiangular. But if you put both of those words and regular, that'd be fine as well. It's no big deal. Okay? All right. Okay, here we go. Let's do this. Let's move on from that. So we're learning a lot of different words here. Let's go back to that diagonal and... Or not diagonal. That's the word I'm going to use in a second. So let's go 5 sides this time. Oops. There we go. All right, so here's something that's got 5 sides. What do we call something that's got 5 sides? It's a pentagon, right? Do you know of a famous pentagon somewhere? Where is it? Washington, D.C. is a famous building. It's Pentagon because it looks just like this. If you go to Google Maps or something and you put in Pentagon, if you see the overhead view, it'll look basically just like this, okay? Except the hallways, they kind of go like this, and then they got this big area in the middle. I have no idea what happens in the middle there. I don't know. But but it's basically 5 big, huge, long. Yeah, it's basically the heart of our military. Um, like the Army, the Navy, the Marines, everybody uses the Pentagon, right? That's kind of like the headquarters for all our military. Okay, but it looks just like this. It's a Pentagon. I'm going to draw a couple things in here that we're going to need to know. And I don't think today we're going to work with these quite yet, but you will eventually. If I connect one corner to another corner, now we don't call them corners. What do we call them when you have a polygon? It's a vertex. Okay, it's a vertex. Yeah, since you said that. So vertex, I don't think we mentioned this. We mentioned the plural of radius, didn't we? What was the plural of that? Radii. And there is a plural of vertex, and it's vertices. Oops, spell it right first. Vertices. That's the plural. All right, so you got 2 what? Vertices. Okay, 1 vertex and 2 vertices. So that's just something that, we'll say that you need to know. This thing right here, if I connect one vertex to another vertex, but you can't connect the one that's right next to it, okay? So you're not connecting from here to here. You're connecting, I think they use a word, non-consecutive vertices. What does that mean, non-consecutive? Well, consecutive means one right after another, okay? If it's non-consecutive, then it's not one right after the other, okay? So if I connected the diagonals from this vertex, okay, how many diagonals am I going to actually have? There's the second one, and that's it. That's all the diagonals I could draw, isn't it? All right, because if I start from this particular vertex, from one vertex, I'm saying, because I could have started here and drawn a couple. I could have started here and drawn a couple. But from that one vertex, how many diagonals can I draw? Just 2 of them. We're going to be doing stuff with that. I don't believe in this lesson. Nope, doesn't look like it. No, not in this lesson. But we are going to do some stuff later on with polygons and diagonals. We're going to do some math with it. We're going to figure out like how much each of the angles are going to be equal to. All right, so we will use diagonals. It's going to be pretty important at some point. Okay. By the way, I don't think we did this because I'm looking at my notes. If I named all these vertices with some letters, we have to be able to name a polygon. All right. We know how to name a line, put the little line with the arrows on it. Line segment is just a line with no arrows. Array is a little line over top of it with 1 arrow, right? We know how to name stuff. We know how to name an angle, right? That little kind of crooked L, right? We use that for an angle. But we also need to know how to name this. Unfortunately, there's no fancy illustration. There's no fancy little way to show it. So we just use the word polygon, right? So if I wanted to name this, if you wanted, you could name it specifically by how many sides it has. But if you want to be general, you could name it polygon. And then what you do is you put all the letters that are in the polygon, and you go in order. Now, when I say in order, you don't have to start at A. It doesn't have to be in alphabetical order. But you could have started at D if you wanted to. And it doesn't matter which direction you go, but if you start going in one direction, you got to keep going the whole direction. So, for instance, the easiest way to call this, I would start with A. Now, you could go A to E and then around this way, or you could do what? A to what? B. So I could call this polygon what? A, B, C, D, E. All right? Now, when you start having like 12 sides, it becomes a little bit of a pain to name the polygon because you're putting 12 points in there. It's kind of ridiculous. But you don't really have to do this very often, okay? But sometimes they will say polygon A, B, C, D, E, or whatever, and you have to look at it. You got to know what they're talking about, right? So you don't really write this very often, but every once in a while they will. So, yep, that's good enough. All right, here's something else. Everybody got that written down? I'm going to erase it because, oops, daisy. There we go. Let's do another vocab word. Seems like we do a lot of vocab in here, and it is true, we do. Let's go like this, and let's go like this. Okay, so what is that thing? It's a triangle, yeah, pretty easy. Now, if we name a triangle, you do have a little symbol, okay? For general polygons and things like that, you don't really have, you just write the word polygon. But when you have triangles, you do triangles so much. I mean, we're going to have whole chapters just on triangles, all right? You do triangles so much, you got a little symbol. So what do you think the symbol is? Little triangle, all right? So you just draw a little triangle like this, and you just name it A, B, C. Now, I could call it ABC. I could call it BAC. I could call it CBA, ACB. It doesn't matter. Okay, any order. You only got 3 points. As long as the 3 points are up there, that's what you call it. Everybody got it? Okay. So that's how you would name that. Now let's talk about this. This is another thing that when I see these things, I'm thinking ahead. And I'm thinking, wow, they really will need to know this stuff, okay? Because we're going to talk about this a lot. We're going to talk about being opposite, okay? We're going to talk about opposite sides. This is probably pretty intuitive, which means you could probably just look at it without me teaching it, and you probably could understand what I'm saying. But I'm going to teach it anyway. So opposite sides and angles. All right? So let's take a look, and this is, again, super important because we're going to do this a lot later on in the year. Let's take a look at angle A, all right? And what if I asked you, what is the side that's opposite angle A? Remember, a side. You can't say angle because I'm asking for a side. You can't just use 1 point because 1 point is not a side. What's the side of a polygon? How many points do I use if I talk about the side of a polygon? 2 points, right? So it's a line segment, right? So it's a line segment. So what is opposite? So angle A, we'll write it like this. Angle A is opposite, I'll just shorten it, but opposite of what? Line segment BC, right there. Do you see it? So here's angle A. If I draw a little arrow, I'm just doing that arrow just to point to it, just to show you, okay? So this angle right here, if I go across from it, opposite, right, that's the side that's opposite that angle. Does that make sense? So what would be opposite? Angle A is opposite what? Line segment BC. So put the little line segment over the top of it, okay? The rest should be easy now. Let's do the rest. Angle B is opposite what? Line segment AC. Very good. All right, see here's angle B up here. And then what's opposite? This one right here. It's the one that doesn't make up that angle, right? See AC right here? It doesn't have anything to do with that angle B, does it? It's the one that's completely opposite, right? And then angle C is opposite, what do you think? Line segment AB. It's pretty easy when you see it, isn't it? So here's angle C, put 3 arcs here, and then boom, that's opposite angle C. You could go the other way. I could say, what is opposite line segment BC? What angle is opposite angle B, or let me say it again. What angle is opposite line segment BC or side BC? Angle A, right? So I could go the other direction too, couldn't I? On that, all right? And again, you may think, where's this going? It's going somewhere, all right? It will. We're gonna look back on this. I'm gonna say, hey, remember that we did that thing opposite? We said we're gonna use it later. Well, here we are. This is later. Now we're gonna use it. Okay, so I promise we will talk about that quite a bit through the rest of the year. Everybody got all that down? All right, there it goes. All right, let's do another word. This word is called perimeter. Probably heard this before. Probably shouldn't be any different. So the perimeter, I just define it as the distance around an object. The distance around they say a closed figure. Let's say what they say because that's probably a little more accurate. Okay, the distance around. This supposed to be a U right there. It looks weird, but the distance around. That's what I think of when I think of perimeter. So if I wanted to measure the perimeter of this room, what would I do? I'd start at a certain point. You could start at a corner. You don't have to, but I'd start at a certain point. I'd measure that wall, then the little in between, small little walls, come around here, measure back to where I started, and that's the distance around the whole entire room. Okay, that would be the perimeter. It's the perimeter of the room. Make sense? All right, so that's what it is. The perimeter is just the distance around something. they give you a little theorem. I think that's dumb, so I'm not going to do that. I'm just going to add up all the sides, okay? I would add the length of that wall, add the length of that wall, the tiny little walls right there, this big long wall, this wall right here. I'd add them all up, and then I'd get the perimeter of the whole entire room, okay? So let's do a couple examples. Pretty simple shapes. And I'm going to put some numbers in there, and we are going to find the perimeter of that particular object. It's a triangle. Let's put some numbers. It's really pretty easy, I think, anyway. I think you will too. Now, when we measure things, if I measured this room, I'd have to measure it in something, right? In some kind of units. Maybe in feet, maybe in inches, maybe in meters, right? A lot of times we use meters nowadays, that kind of thing. So we got to measure it in something. And the book uses centimeters for all of these. So let's put that in there. So here's the question. I asked you to find the perimeter of this object. So what would you do? Just add them up, okay? Now, on a homework, you need to show where you're getting your answers, okay? I mean, I know you could probably do this in your head, but I want to see how you got the answer. So I would put 10 plus what? Plus 4 plus 8. Really doesn't matter. Doesn't matter what order you put it in. No. But that shows me how you're getting the answer right there. I think that's pretty important for you to do, all right? It's that 12 and 10 is what? 22. And it's in centimeters, right? So we always put the unit because we need to know, could be, 22 could be miles, right? That's a lot different than 22 centimeters. So make sure you put the units, right? And that's it. That's how you do perimeter. Yeah, that's good enough. Oh, I thought I was going to be able to finish this before the end of class. I only got 1 more minute left, and I don't have enough time to do the rest. So the rest, we're going to talk about a circle, okay? We're going to talk about the perimeter of a circle. So we'll save that for tomorrow. Now, you should be able to do the homework from last night, okay? If you already did it, great. But you should, I think we've covered everything up to that point. So it's, what is it? 31 to 43? Okay, that was yesterday. So it's 31.
13 to 20. 13 to 20. And 40.
Oh, I missed that. 13 to 20. Thank you. So it's 13 to 20. And what else did I say? 31 to 43. Okay? So that's your homework. Have that, have that finished for tomorrow. Tomorrow the lesson should only take 5-10 minutes. And then I'll let you work on the next assignment in class tomorrow.